Hey guys, and welcome to this second video from what to smart grids. So in this one I'm going to talk about traditional electric networks, how they function. I'm going to address storage, equilibrium and transport. I just would like to mention that I am not an electrical engineer, I am a business student, so we will not go through technical details. My goal is really to provide a basic understanding of power systems. Okay, so first we will talk about storage, and the first thing you need to know with power system is the fact that electricity cannot be stored as itself. So electricity is a movement of electrons and you cannot store it. I mean, unless in supercapacitor, but we will not talk about this in this video. So this means that every time you plug on your cell phone, you turn on the TV, you turn on the light, or any action that consumes electricity, at the same moment, we have a generator somewhere which will be producing the electricity that you are consuming. So every time, I don't know, you go out, you see street lights or trains, you have to realize that why these devices are working. At the same moment, you have a power plant which is providing a constant flow of energy. So it's quite tricky for power plants because they need to know how much is going to be consumed by the population or by the industries, and they have to adapt their production. So if power plants produce too little or too much electricity in function of the real consumption, you can have consequences on the grid which can lead to blackout or even break the grid. So it's very tricky, and power plants really need to adjust their production in function of the consumption. So it's real-time adjustments. Okay, so now we know that electricity cannot be stored as itself. We realize how the concept of equilibrium is important in power systems. So the production of electricity always needs to match the consumption. If it doesn't, it can lead to grid damages. So let's go through a quick explanation to see how it works. So as I said, yeah, the production has to match the consumption, but most of the consumption can be forecasted. So you know that industries will consume this amount of electricity, that people, when they will come home after work, they will start cooking and so on. So you can forecast the majority of the consumption. So you can see here, for example, you have the consumption of one day, and you can see that most of it is already full of electricity. So it was planned. But for example, this little part over here, you have some uncertainties about how much is going to be consumed. So it's little amount, but these little parts are monitored on the frequency market. So the frequency in Europe is supposed to be at 50 Hz. So 50 Hz is the normal frequency. It's in Europe and in most of the world. In the US and in other countries, they have 60 Hz, but we will go with 50 Hz. So let's say that now we are at a perfect equilibrium. So 50 Hz is good. So now the consumption is going to increase. The frequency will decrease until power utilities will start increasing their production. So now power utilities increase their production and we are getting back to the normal level. Now the consumption is decreasing and we have too high frequency until power utilities will start decreasing their consumption. And so you can see that making sure that the production equals the consumption, at the end it's through the frequency that it is done. So the frequency always needs to be monitored. Okay, so now we get to the last part of this video, which is transport of electricity. So the first thing you need to know when you talk about electricity transportation is your goal will be to increase the voltage in order to reduce the power loss. So the formula for power loss is the following. So it's the current squared times the resistance. So for an equal amount of power, you will have the voltage and the current, which is the amperage. And your goal will be to increase the voltage to decrease the amperage. So in this way, you will have an amperage weak, and so you will have less power loss through transportation. So let's start with our examples. We have a dam and a nuclear power plant, both produce at 20 kilovolts, and through the transformer, which is the device which allows you to change the level of voltage and amperage, you will reach a voltage between 220 and 380 kilovolts. So this is the highest voltage you can have in a single system because it's on the transmission. The transmission is where electricity is supposed to travel big distances. So your goal will be to increase the voltage as much as possible in order to limit the power loss. So when the electricity went through the transmission system, it will come in the distribution system. So in the distribution you have different subcategories. So you start with the supra-regional distribution. One thing I should mention maybe, this draft is specific for Switzerland, but every country have system more or less similar. So when you start with the supra-regional distribution, you have between 36 and 150 kilovolts. You have certain type of companies which are big electricity consumers, like train companies or other big industries, I don't know, steel industries and so on. They consume a lot, so then they have a direct access to this kind of distribution because they will require a lot of power. Then you get on the regional distribution. The regional distribution, again, the voltage is lower because you will feed cities, big buildings and villages. And finally you end up with local distribution, which is the smallest possible, so we'll have at max 1 kilovolt, and this one will be more for remote places, houses and so on. So this is, yeah, that's it for the transportation of electricity. And now to make a little link with what we talked before about the equilibrium, the distribution system operator and the transmission system operator are going to be the stakeholders responsible for monitoring the frequency. So they have the grid, and so they can see if the level of frequency is too high or too low, and depending on the signals, the power plant's operator, they will adjust their consumption, their production in real time. So I hope my explanation was clear. I just would like to thank you for watching it, and if you could give me a thumbs up, it would be very appreciated.